Now, we're familiar with the notion of an absolute value from our previous experience. Remember, the absolute value just says, take whatever x is, take whatever's inside the absolute value, and make it positive. So if we take the absolute value of a positive number, like 4, that's just 4. If we take the absolute value of negative 2, well, make it positive, that's going to be a positive 2. And so on. 0 is special, absolute value of 0, right, that just stays 0. It turns out that we can think about this as a piecewise function. In particular, this function does one of two things, depending on whether the number is negative or not. If the number is not negative, right, so greater than or equal to 0, not negative. If the number is not negative, we just leave it alone. So positive numbers, we leave them alone. 0, we leave it alone. If the number is negative, okay, this is going to seem weird, but it makes sense once you parse it. If we have a negative number, what I've written there looks like negative x, but this makes more sense if we read it as the opposite of x. So if the number is negative, we take its opposite. In other words, if I want to take the absolute value of negative 2, that means I take the opposite of negative 2, which is a positive 2. It feels a little bit weird to write that with a negative sign, but remember that that just means take the opposite. When we take the opposite of something negative, we get something positive. The cool thing about thinking about the absolute value this way is that this tells us what the graph of an absolute value function is going to look like. Suppose we want to graph f of x equals the absolute value of x. Well, what we're doing is we're graphing f of x equals x if x is greater than or equal to 0, the opposite of x if x is less than 0. This is a piecewise linear function. We'll set up some axes, and I'm just going to kind of set up axes with the origin in the middle because we don't know what our graph is going to look like yet. Here, the y-axis is where we split our graph in half. To the left of the y-axis, we're going to be graphing negative x, and to the right, we're just going to be graphing x. So, at x is less than 0, we're going to use negative x. When we put x to be 0, well, negative 0 is still just 0, right? 0 is its own opposite. So we'll have an open circle at 0, 0. And then pick any negative number. I'm going to pick, say, negative 2. The opposite of negative 2 is 2. So that'll give us the point negative 2, 0. And we just draw that line. When x is greater than or equal to 0, well, then we'll just use the expression x. For x is 0, we just get 0. So that's the point. 0, 0. That gets a filled in dot. And now I'm going to pick, say, x is 2. So that will give us the point 2, 2. And that's the graph of the absolute value. We describe this as a V shape. Specifically, the graph of f of x equals the absolute value of x is going to be a V shape with its point, literally the pointy bit of the V, at 0, 0, and opening upward. In later sections, we're going to see how we can take this one graph and turn it into any graph that uses an absolute value.